Alright, in this section we're going to solve equations that have fractions in them, and basically our strategy is we take an equation with fractions, turn it into an equation with no fractions that we already know how to solve. The way we do this is identify the least common denominator and just multiply both sides by the LCD. So here's one to start out with. The denominators are all numerical. The LCD of 12, 8, and 6 is the least common multiple, so that is what, 24. So I'm going to multiply 24. I write it as 24 over 1, just to kind of help aid my next step. The reason I'm doing this is because I want all the denominators to cancel. So that's my next step. 12 goes into 24 twice, 8 goes into 24 3 times, 6 goes into 24 4 times, and then this equation becomes 2x minus 3 equals 4 times x plus 2. Note the parentheses, right? I have to make sure I'm multiplying that whole numerator by 4. But this is a linear equation now, not too hard. We'll start by distributing that 4. So we got 2x minus 3 equals 4x plus 8. We can, let's see, subtract 4x and add 3 to both sides. I'll move this over here. So that yields the equation negative 2x equals 11. And now all that's left to do is to divide by negative 2, and we get the result x is negative 11 halves. Alright, let's try another one. Here the LCD, all the denominators are already factored here, so I don't have to worry about that. I just want to make sure I pick up all the factors, so I need a 2 and an n plus 2. So I'll multiply now both sides by that LCD. I do that so that my next step I will cancel, right? When I multiply both sides by the LCD, I'm not going to expand all these products up top. The first thing I need to do before I do anything is cancel these denominators, because my the next equation that should result after I multiply through by the LCD is to have an equation with no fractions. On the left side, 2n times 5 is 10n. On the right side, I have 3 parentheses times n plus 2, another linear fraction, or linear equation rather, which we know how to solve. So I'll distribute that 3. Let's subtract 3n. Get all of our n's on one side. Gives us 7n equals 6, and now it's all over but the shouting. All we need to do is divide by 7, and we get n equals 6/7. Okay, let's try another. The first thing we want to do is identify the LCD. That's going to be fairly simple in this case because the denominators are already factored. So here the LCD is 3x. I need a factor of 3, I need a factor of x, and that takes care of all of our denominators. I'm going to rewrite this, leaving just to leave some space, basically. So I multiplied both sides by 3x. That means I'm going to multiply all terms by 3x. Every term's going to get zapped with a 3x. I'm going to cancel what will cancel. The The first term ends up being 3 times, in parentheses, x minus 3 equals, on the other side, we have 3 plus 2x. I'll distribute that 3 against another linear equation, so I'll distribute that 3x minus 9 equals 3 plus 2x. Get all of our x's on one side. Let's subtract 2x and add 9. And that gets us x equals 12. All right, one more to go. Again, our denominators are factored. If we had denominators that were not factored, the first thing we would do is factor those denominators and just make sure our LCD includes all of the factors that are present. This already being factored makes it easy to identify the LCD. So this 2 is a 2 over 1, so we don't have to pick up any factors there, but we need a factor of x, we need a factor of x plus 2. I always rewrite the equation leaving myself some space because I know I need to be able to write out that I'm multiplying by that LCD. In the first term now nothing cancels because of course the denominator is just 1, so I've got this product 2x times x plus 2. In the second term the x's cancel and I'm subtracting x plus 2, but I'm subtracting the whole thing. I'm going to be really careful with my signs here. I need those parentheses. And then over here on the other side the x plus 2's cancel. And we get 3x. Alright, so now this one ends up not being linear. I'm going to expand out the left side. I'm going to distribute that 2x. We get 2x squared plus 4x. I'm going to distribute this negative. Negative x, negative 2 equals 3x. I'm going to subtract 3x from both sides. So now what we have going on here with our x's, 4x minus x is 3x, 3x minus 3x, so the x's are completely cancel out. We end up with 2x squared minus 2 equals 0. This is a quadratic, so let's recall, like, one of the ways we can solve a quadratic is to see if it'll factor. We could definitely take out a 2 here. And once we do that, now you might recognize this, we've got a difference of squares, so we could factor this all the way. And if we have a product set equal to 0, the only way that happens is if one of the factors is 0. And that gets us two solutions, x equals negative 1 and x equals 1. Now we're one more step in this type of situation. We have to make sure, when we solve an equation with fractions, and I didn't make much mention of this before, but when we solve an equation with fractions, we have to make sure that the answers that we get don't cause us to divide by 0 in the original equation. So we got x equals negative 1 and x equals 1 for our solutions. If I go back up to the original equation, I'll note that x equals negative 1 and x equals 1, neither of them would make us divide by 0, right? So I'd just be on the lookout for what's in the denominators, and if I plug in any of my, the values we found for x, does it make any of them 0? It doesn't in this case, so these are both work out just fine. And we could just really quickly just note that here x equals 12 doesn't make denominator 0, and n equals 6/7 doesn't make either of those denominators 0 either. And of course, our first example, there were no variables in the denominators to begin with.